Hello, good people of the Commonwealth. Today I would like to elevate my fellow construction brothers and carpenters. I want to go over some angles and trigonometry, the elusive trigonometry. Oh, so complicated and difficult in school. For the most of us, probably. Most of us that ended up actually needing it. Funny, right? But fear not, it's not that difficult. We're going to make it real simple and hopefully get you guys to where you can use all the trigonometric functions to figure out the angle you need or to figure out a side of a triangle with an angle. And do it pragmatically. Okay, first, a refresher on the Pythagorean theorem. A squared plus b squared equals c squared. It's just a refresher because it's fundamental to triangles, and it's also going to be important just algebraically, real quick, just to go over just those stupid little algebraic rules, right? So a squared plus b squared equals c squared. So if we have a triangle, it's 3 with the height and 4 on the base, then c is our hypotenuse. That's what that is, right? So if we plug those in, 3 squared plus 4 squared equals c squared. Do the math on those. 9 plus 16 equals c squared. 25 equals c squared. Then we do the opposite to get rid of that squared, right? Remember that? So we take the square root on both sides. Square root of c squared is c. The square root of 25 is 5. Oh, look at my typo. Why did I write 25 again? So c equals 5, right? And that's your basic 3, 4, 5 triangle. You should know that already for how to square things up. 3, 4, 5. Very important, fundamental. So then what happens if we already have 5 and we had 4? How would we do that? We plug that back in. So again, a squared, now that's what we're looking for. A squared plus 4 squared equals 5 squared. Do the math. A squared plus 16 equals 25. Now, remember, do the opposite on both sides. We want to isolate our variable that we're looking for. So minus 16 on both sides. And we get a squared equals 9. Square root of a squared is a. Square root of 9 is 3. Again, 3, 4, 5, right? Real quick, simple, easy. Just going over Pythagorean theorem and that basic little algebra that you might have forgotten. So now, let's get into the trigonometry. Trigonometric functions, sine, cosine, and tangent. SOHCAHTOA is still very important. If you can remember that, it's pretty easy. I got it written down up there. You can see it. Now, those functions with those sides, okay, these functions are designed to give you a side given an angle and a side. Okay, and then the inverse of those functions can be used to find the angles. That's how that works. Just very simple and plainly. Okay, if you understand that, really, if you understand SOHCAHTOA, you remember that, and you understand the algebra that we just did as far as doing the opposite on both sides, and you can remember that the trigonometric functions themselves give you an angle, or give you a side given an angle and a side, and the inverse will give you the angles given sides. Like, you're already 90% there. You could go figure it out right now for yourself if you wanted to. But I'm just going to be here to go over it, make it a little easier. So, what do I mean? The inverse will give you the angle. So let's look at a very practical first example. Say we have a roof pitch, 8, 12, right? And just up here is our little drawing of the triangle in case you forget. Our angle, that's opposite our angle adjacent our angle, and then the hypotenuse is the longest guy, right? So if we have an 8 pitch, that's at 8 degrees rise for every 12 degrees run. We know TOA, tan, is opposite and adjacent, opposite and adjacent. So to find the angle, we take the inverse tan of 8 divided by 12. Okay, because these are all, the angle equals, like the tan of the angle equals 8 over 12. Okay, we'll get into it where it really matters later, but for right now, this is how you find an angle with a rise and a run. A tan, rise divided by run, right? A tan, A12. What does that give us? It gives us like 34 degrees. It's like 33.9 or whatever, okay? Where else is this useful? Stairs. We have a rise is 7 3/4 and a run 10. How do you figure that angle? How do you know that angle is within limits? How do you cut base to go up and over the angle, around that stairs? Well, you plug same thing. A tan 7 3/4 divided by 10, and that'll give you your answer. That's like 42, something like that. So that is tangent. Now let's work to cosine. And now we're going to use cosine to figure things like rafter lengths, okay? So cosine is going to be our run divided by the cosine of our angle. That's how we're going to figure out our hypotenuse is, okay? It's really just as simple as that. It's the run divided by the cosine of the angle. So if our run is 126, assuming that's half our run minus half our ridge, right, which is how you figure rafters, 126 divided by the cosine of 34 equals 152. That's the line, or about, I rounded, I think it's 151.9 or whatever. It's probably like plus a 16th or whatever. But for all intents and purposes right now, 152, okay? That's your rafter length. That's how you figure that. Over here, we've used tangent to figure out the angle. Here we've used cosine to figure the hypotenuse, given the angle, okay? This is important if they give you like a pitch on a print, and now you're figuring out the length of a rafter depending on a pitch and your measurement in field, right? You're going to be able to figure out your angle with a tan and then figure out the length with cosine. Now, what else are you going to need to build? You're going to have to build your scaffolding to set the ridge, right? How do you know how high to set the scaffolding? Now we're going to use sine, because we figured out hypotenuse. We want opposite. We have hypotenuse. We'll use sine. So again, like I was saying, sine of the angle equals opposite over hypotenuse. Okay, that's how you set up those functions. So sine 34 degrees, because we have the angle, equals opposite divided by 152. So what do we do? Sine 34, we're gonna multiply by 152. We're doing the opposite, like we were doing down here, right? So opposite sine 34 times 152 gives you 84.99. That's your this side. That's your height. And literally right there, we've just used all of the trigonometric functions and the Pythagorean theorem to do master level carpentry shit. If you can do this, You can 3, 4, 5, and 6, 8, 10 stuff. That'll make it square. Super important. Check for square, right? You have to be able to do that. And then if you can figure out the angle and figure out your rafter and figure out your scaffold height and all these things, you're way ahead of the 8 ball. Way ahead of the curve. A lot of people don't know that. You know, a lot of this is stuff that like this is what separates a lot of like carpenters, regular journeyman mechanics from like foremans. It's just knowing this kind of stuff. And it's not that difficult. It's really, I mean, think about it. What did we learn it in like 9th or 10th grade? It's like 9th to 10th grade stuff. Like 13, 14-year-old kids can understand it. And, you know, they teach it to you in a shitty way. But I feel like if you can just memorize these things and understand the concepts that we were going over, as far as the algebraic concept of doing the opposite on each side to figure the variable, right? And you can just memorize, even if you just memorize, like you just memorize a tan rise divided by run gives you an angle, and then run divided by cosine of the angle gives you the length of the rafter. Like that should kind of set up a frame of reference in your mind that really sets you up to be able to understand how the functions work and help you be able to figure out anything else that you need to figure out if you need to. Don't be afraid to come over here and be like, what's cosine of 34? I don't know how to figure out what I need to figure out. What's cosine of 34? Oh, 0.82. That's close to 1, but it's a little bit less. That means it's going to be a little bit bigger, right? Like, so you can kind of see just by putting in that number, because that's the ratio, right? That's giving you a ratio of your hypotenuse to your run. So you could think of it as per 1 unit of run. I'm sorry, for 0.8 units of run, basically, you get 1 unit of hypotenuse, I think, basically. Something like that, right? But you understand, it's a ratio. And you can do that same thing with like the second sine 34. Sine 34. That's 55. That's like half, right? And remember, like 3, 4, 5, your opposite is like almost half, right? So now you can kind of start to see. So if you divide that by the other one, or sorry, multiply it in this case because of the algebra, then you're gonna get a number that's about half, right? A little more. And so don't be afraid to take out the calculator and just start throwing in some numbers, you know, throwing in angles into these functions, right? And then throwing sides divided by sides into the inverse trigonometric functions. And that is it for that. I think that's a good like little introductory course into that. I'll make another one another time, really going over how to figure out stairs and rafters and maybe hip rafters, but that's kind of like, it's complicated. That might be worthy of its own video. Hip rafters, those are crazy, because those are, you know, you have to figure it's on a 45-degree angle. So yeah, it's fun. But that should get you guys set up. You guys should be going into work tomorrow, freaking cutting trim around stairs and fascia and all sorts of crazy shit. All right, let me know how you guys liked it. Let me know if you learned anything. Appreciate y'all. Be good.